Hi, thanks for joining me here in my shop. Hey, I'm a happy guy now because the problem with this unit is solved, the main problem anyway, and guess what the main problem really was? The main problem is really me, of course, because I'm the guy who shoved the tube into the socket incorrectly. I mean, you can't do that, can you? But somehow I found a way to do it. And really, for the last 20 years, this machine has been sitting, waiting for an opportunity for me to find out what mistake I made with it earlier. Now, I gotta defend myself a little bit. I did find a wire disconnected, oddly enough, it's the strangest thing, 20 years ago, and reconnected that wire. That wire runs right over to the voltage regulator tube, the tube that was in the socket wrong. Almost certainly, while I was troubleshooting, I traced that wire down. I pulled that tube out 20 years ago, stuck it back in. You can't see the socket normally on this. You cannot look down into it. You need a little tiny camera or mirrors or something like that. So I'm just putting it in by hand, as I've done so many times. You can put in a tube blindly into a socket if you're careful and you rotate and feel, rotate and feel. You can find the spot where it goes. And you can also, as you push the tube down into the socket, you can feel if that's going into a socket properly or there's something weird going on. And then once you get it into the socket, you can wiggle the tube a bit, and again, you can kind of feel if it's being gripped in a normal way or if it somehow doesn't seem right. Even how it sits in the socket. On the Hammerland radio, I have managed to plug tubes in and have pins actually miss the socket, the outer edge of the socket entirely. It goes in part way, feels like it's plugged in, resistance when you try to pull it out, but it doesn't feel normal, and it doesn't look centered in the socket sleeve. So yeah, I have actually had this kind of problem before. So anyway, enough talk about the tube and all that. The simple thing I got to do now is do a little bit of calibration in here. For sure, one of these calibration adjustments, the P4 adjustment, which is down here, I think I've got it set right to one of its limits right now. And I was trying to accommodate the missing voltage regulator by doing that. So I got to set that one back. So what I've been doing here, there's no need to study this carefully right now, so I'll just hold it up. Yes, I lost a whole piece of it here somehow. So there's P4. You know, I can tell that this is the right control for a number of reasons, but it says right on it, right there above the pencil, it says INT for internal, as opposed to the control being on the front panel. Another hint is the size of this potentiometer. It says 5K, and the potentiometers are marked quite clearly on the surface of it, what they are. So P4, and I can't see in the dark here, says 5K, so that's that. So, you know, by hook or by crook, I've been able to figure out where these are, but this machine is not through with me yet. So take a look. Here's P4, P3, I don't know, I guess potentiometer. Potentiometer 3, potentiometer 2, and then down at the bottom here, potentiometer 1, right here. This one is installed with long lead wires. There's long lead wires going in behind here. The other ones are installed very close to the circuitry that they affect. So here's the thing. 4 of those adjustments, I can only find 3 in the schematic, for crying out loud. Now there's a lot of stuff on here, but this whole area I'm kind of covering here, this whole piece, everything inside this dotted line square here is inside a can. It's inside this. I haven't even taken this off. So there's tubes in there, there's racks of resistors and all kinds of stuff inside there. So, but the adjustment I'm after is not inside there. The adjustment I'm after is out here. There it is. It's sitting right out here. And that's this part of the circuitry down here. That's outside of the dotted line shield can, as they represent it here. So somewhere from here all the way to here, P1 has to appear, and it does not. And I have stared at this thing for almost half an hour. I've gone component by component with my eyeballs trying to spot what it is I'm missing. And I cannot spot it. Now, they have not put P1, P2, P3. I've written them on here. And I've sorted these three out. These two for sure. I've been able to trace, first of all, there's only 2 wires coming to the potentiometer. Only 2 wires here. That P1 has 3 wires coming from it, so it can't be these. And these ones, I've been able to spot their connections into the switch, down into the switch where there's a couple diodes. So I've been able to prove these, so I don't have any doubt. P2, P3, P4. What's up with P1? Now, if you remember early on, one of the earlier videos when I first got this schematic, I noticed it's an unsigned drawing. Okay, it's just got the initials of the technician who sketched it out. And it's got a big warning sticker over here. Don't give this to anybody. So this could be very much a preliminary drawing, and they may have made improvements, and there may be a version 2 of this drawing somewhere, who knows where. This is what I've got to go on though. So I have to guess a bit now. What is P1 all about? So P1, as I said, has wires coming up the back. Let's take a look. We'll follow this out. So there's P1. There's the 3 wires, white, blue, and red, and they travel along here, They make a turn, and they go down through that hole. Okay, so that hole, they couldn't have, that hole, just making sure, okay, around the other side is that hole right there. If you look close, you can see the blue, red, and the white wires. And here they are, they're splayed out. You can see them right there. And what is that? What is this? This is the a switch that controls the operation of the front panel meter. This doesn't actually affect the operation of the signal generator itself, just the VTBM meter. Look, there's another one of those. A very small, it looks like a Hunt's capacitor. There's another one back here I never noticed. Yeah, I should take a few minutes and get rid of those capacitors. So, so what am I saying? I'm saying I lost my track. Where'd it go? Yeah, so the wires come up, they go into this switch. Now on the schematic, I don't think there's any grollery. That's not the right word. Let me fix my focus here, please. Bear with me just a sec here. Again, less prepared than I should be. There we go. Let's just back it down to here. So here's the switch. That complicated looking switch is sitting here. Here's the 2 diodes that we saw. These 2 diodes. Sorry about my camera work here. Right here, one here, one here. Right on this big honker of a switch. That's a busy item, isn't it? So, what would they want to put in as a missing calibration in here? Oh my gosh. I was going to suggest maybe one of these 2 resistors in the bridge circuit here. Perhaps they've turned that into a variable. But if they did, it would only require 2 wires. It wouldn't require 3. It would be wired up like this one, up here. You know what? I have no clue what that control is controlling. Maybe it's in addition to this. I notice this control, which is on the front panel, and it says 5K here on the diagram, in fact is a 10K. And you can see it right up in here. 10, that says 10K there, that brown thing. So maybe it's been done in conjunction with this. I don't know. My problem is, should I try turning it? I guess I can always return it to whatever it was set. So if I turn that control and I can't see anything happening, then how am I ever going to know what it's doing? I don't know. Or just ignore it. Just ignore it and leave it. And concentrate on doing these 3. This one's easy. That's the 160. This one, let's see. Calibration of VTVM. It's on the carrier line here. So it must be calibration of the carrier setting of the VTVM. And this one, it says right on it, mod meter, MOD, modulation meter. So we calibrate the modulation percentage here. And you calibrate the VTVM voltage here. Wow. You know what I'm going to do here? I'm going to leave this like it is, because I don't know what to do with them. Lots of thoughts going through my head here rapidly I'm not talking about. But it's around, how would I know how to set this? Maybe give some hints down in here, I don't know. This one's easy though. Adjust this and measure the potential up here. So this one's pretty easy to do. This one I know is out of whack because I whacked it out. These ones I don't know that these are incorrect. And P1, who knows what's going on with P1. That's my thinking here. Too much thinking, not enough doing. So what we'll do is we'll set P4 to 160. So we get 160 here. We'll then run a bunch of tests on the generator, sort of general tests of the generator, and see what it's really doing. And then from there I can consider whether I want to try to fiddle with these or best left alone. Probably best left alone, really. You know that old thing, quit while you're ahead. Well, the next thing you know, you won't be ahead anymore. Okay. So that's a simple matter of finding the 160 test point. 160 test point. I've got the 160 test point. I'm trying to remember, where did I pick that off? See, 160 comes all the way down here, goes on the pot of the 0 control. On the so I should find 160. That's pretty easy to spot, that point. So that's the point we'll measure, and we'll adjust. Okay, so that's just, see now, clip onto that point. The generator's not operating, so it hasn't been on yet today, in fact. Okay, so that should have 160 volts on it. I'm going to use my digital meter here because I'm pretty sure it's accurate. Click that on. Pretty rough camera work there, eh? Hey, talking about camera work, I watched a movie on my new great big screen TV. I'm into war movies these days. I'm going over the history of the Second World War, and I'm watching movies and documentaries and stuff like that to try to get my head around that war. So the movie I watched the other night was Patton, a movie about General George Patton, American general in the Second World War, who was a very interesting character, and that's the best way to put it. Here's the thing about watching this movie on a big screen. I was floored. I started watching this movie as soon as it started. I was watching it on Netflix, so it's coming off Netflix. The movie was made in 1957. It used a broadcast or a film technique called Dimension 150. So I think it was only around for a couple of years. and it could produce super duper widescreen shots. Great for a war movie, of course. The thing that floored me is, it was like watching high definition television. It was like watching a modern production. In fact, it was so sharp and so clear on my big TV. I think it's a 1080p signal coming at my TV, and I'm guessing somebody took the original film and remastered it, or whatever they did to produce the copy I watched. I was floored, and I shouldn't have been floored. Of course they could film in super good detail and beautiful focus and all this kind of stuff back in 1957. Of course they could. They could do it probably 20, 30 years earlier. It's just I've always been watching it on crap televisions. And when I was a kid, little black and white fuzzy televisions, and just right up until this moment. This is the first time I've looked at an early film, and there's a reason why I'm telling you all this, at an early film on a big screen TV, and a psychological effect gripped me that I'd read about. When I went to buy my TV, before I went to buy it at Christmas time, I read up, like anybody, got on the internet, I read up, and one of the things I read about was this curious effect where very, very clear images on your big screen TV of old movies can cause a psychological effect where you cannot look at the movie as anything other than a stage play. That's the best way to describe it. When you look at the actors and the sets, they stop looking real and start looking like you're watching them on a stage. And of course, that's really what's happening. You really are watching actors on a stage. It's fake, right? Most of it is fake. The outdoor shots, this effect didn't really hold, but on virtually all the indoor shots, as soon as they started, I got this terrible, uncomfortable feeling that I could not maintain the level of, what do they call that? Shoot, where you shut off your critical thinking to a fair degree and kind of go with it. I couldn't do it. I still watched the whole movie. It's an interesting movie. And fantastic military. I mean, there's a reason why this movie is considered one of the better World War II movies. But this psychological effect, it made me think a lot about what's going on with video and all this kind of stuff. Okay, is that enough talk? That's enough talk. They're all waiting for me to fire this guy up and test it, and so am I. But I really wanted to share this thing. I wonder if any of you have experienced this, because lots of people have. Very large. My TV's over 50 inches. On the diagonal, it's a big one. I wonder if anybody else has heard of this or noticed this effect. And I also kind of wonder about my own video shooting and stuff like that. But anyway, enough talk. What am I doing? I totally lost track. Yes, in case you've noticed, I'm easily distracted. Hey, that's a great way to go through life. Don't ever kid yourself. He says, trying to distract the audience right away. Okay. Now, I think we're good to go here. Switch is on. Meter's connected. It's set to 200. I need to get a screwdriver ready here. Ready. I need a screwdriver to make the adjustment. Well, we can switch it on and let it warm up here anyway. Okay, we'll see. Quick safety check. Make sure all the tubes are in. Yes. I would not be so silly as to leave a tube out. Okay, we'll turn the carrier level down. Power on. There we go. Full power. Now I'll find that screwdriver here. Very soon my screwdriver rack will arrive in the mail. I had to order a screwdriver rack over the internet. So I cannot find them anywhere. There, 178. Anywhere in any stores. Any decent racks. Okay, P6 now. Did I say P6? P4. There is no P6. There we go. Hold still. Okay, I'm doing a bad thing. See my hand? You can't see my hand. I got my hand on the frame like this. How do you get a shock? That's one way, but I gotta hold this thing still. There you go. That's how it would happen. Let me hold the wood here. Be smarter. going to use the one hand. Here we go. Here we go, the one hand law. Oh, look at that. Well, that's pretty accurate. 160. Fantastic. Now, let's take a look at the front panel meter. I'm going to take this wire off here. Okay. Front panel meter. Make it just a little more visible. I'm not sure if you're going to be able to see this or not. The camera. Okay, the meter is currently right down near the bottom, but I've got the carrier. So you set the carrier, 2 volt. Oh, fantastic. There it is. 2 volts, no problem. The band I'm on is a 1.5 to 5 megacycles. Let's go up. Because it seems to me the higher you go, the harder it gets to do its thing. Okay, we're just under 2 here. Adjustment. You know what? Basically full blast gets it to 2. Now wait, modulation should be set. I said this would not be accurate if it's done with modulation. I set this to attenuator and it made it to the 2. Fantastic. Okay. This would normally be set to an attenuator. This is the attenuator, this control, and this control combined to drive these outputs. This output down here. This one here is kind of ahead of the attenuators. This shows the voltage being fed into the attenuator system. And depending upon how you set this control, you can dump everything to this terminal to maximize this thing's voltage and current output here. So how you set these is going to affect things a little bit. 2. Let's just tune the range here. You'll see it's dropping way off. Way off, way off. It's not going to work. Down there. It's way up and over now. Way up and over. It's going down in frequency. Down 6, where are we here? 7 megacycles, and we've lost. That's too bad because that's a really important range. Now, I can still use the instrument. I can read the voltage here, assuming this is accurate, and I can calculate what's coming out of these terminals. The difference is when you run this machine with this setting under 2, the stability of the output voltages and stuff is poor. It's its own internal regulation. Well, it's not regulating well anyway as I dial around here. So it doesn't make it impossible to use. In fact, if I can set it to 1 volt, which I can't quite get there. Now, hey, good question. Good question. Is it the meter? Is it the meter that's not working? And the actual voltage is coming out fine? And I'm just looking at a meter and being fooled? Good question, because you see all the circuitry associated with the meter. Okay, we're going down to, whoops, it just went up, went up, went up. So that's, I just thought, whack, the meter just went over and kapowie. So a lower frequency, getting more power out. Okay, we're at 1 extreme, no problem hitting 2. Other extreme, no power, no problem hitting 2 volts. So you know, the machine's on its side here, for crying out. I keep looking, I keep looking in the wrong places. So, lower scale yet, 150 to 500 kilocycles, 2 volts, no problem. And what are the chances that this is in the lower band, 50 kilocycles to 150? And the meter's just gone right to 0. Still got some oomph in it, but oh yeah, a little surprised at that. It's going right down. It's going up a little bit. We're up around just above 0.5 volt. So like the extremes of this machine just isn't working all that well. You know, she goes okay at 60 miles an hour, but don't try passing anybody. That's kind of where we're at with this. This extremely low frequency I'm not terribly interested in. The one that's bothering me here, let's just check it again, is the 4.9 to 16 megacycle band. By the way, here's the highest one, 15 to 50. Can only make it to 0.5. Now it's going up. Oh, just about made it there. Almost 2 here. Okay, now the band I'm a little bit concerned about. Oh no, it's gone right over here. Ooh, lots of power there. I'm at the 4.9 to 16. So I'm at the high end of the band rate now. 16 megacycles. 15, 16 megacycles. And we'll come down. It's going down, down, down. Turn it back up. Still there. Still make it to 2. Now I can't make it to 2. So the 2 volts stops right around here. It really drops off right at the end of the range here. Down to 0.5. Again, is it the meter or is it the actual device? So we'll have to measure the output. The output actually coming out of these terminals. I've certainly learned that that's easier said than done in many cases. Yeah. Just thinking very hard here, very quick. Quick and hard. Thinking quickly and hard. Thinking quickly and hardly. I'm hardly thinking. Okay, so I'm going to hook up some kind of connection here. And luckily, I just found the cable that was making me hesitate so much. Let's give it a shot here quick. So we're going to hook up the scope here. There we go. And we're going to try to do it kind of direct. So we'll take it off of the 50 ohm output. That's this one here. Okay. Show me a connector. Somebody, anybody. Okay, gotta stop the video, gotta go find the connector. I know where it is, but gotta run for it.